Welcome to Physics 2211, Lab 3, Black Hole and Orbits. This lab is broken into two parts. Part 1 focuses on calculating the mass of a black hole given a known mass of a star and its trajectory. Part 2 explores the influence of a multibody system on the orbit of a spaceship. The goal is to find stable orbits, including a figure 8 orbit, by adjusting the initial velocity of the spaceship. Key concepts include Newton's second law, which states that the net force acting on an object is the change in momentum over the change in time. The velocity and position update formulas are related and incorporated into the code. The second key concept is the parallel and perpendicular components of the net force. These components are related to the change in momentum over the change in time. The parallel component is parallel to the direction of motion and impacts the change in speed of the object. The perpendicular component is perpendicular to the direction of motion and impacts the change in the direction of the motion. Another key concept is the universal force of gravity, which states that the gravitational force of an object due to another object is an attractive force that is proportional to the masses of the objects divided by the square of the magnitude of the distance. We'll get back to the second equation in the Part 1 experiment. These are the free body diagrams. Grayed out arrows imply the object's location is fixed. Part 1 shows the gravitational force in the black hole on the star, which is used to find the mass of the black hole. The system is the star, and the surroundings are the black hole. Part 2 shows the gravitational forces between the planet, moon, and spaceship. The initial velocity for the spaceship will need to be greater than or equal to the escape velocity from the moon to find a stable orbit. The system is a spaceship, and the surroundings are the planet and the moon. These are snippets of code from the Part 1 computational model. The initial conditions include the gravitational constant, the mass of the star, and the time interval of 1 Earth day in seconds. The change in momentum over the change in time is computed within the while loop at line 171. The parallel and perpendicular components of the net force were computed below beginning at line 177. The last snippet of code at line 190 calculated the mass of the black hole using the aforementioned equation, which was converted from the universal force of gravity. Here is Part 1 running. The average mass of a black hole is calculated to be 1.024 times e to the 34 kilograms. For the Part 2 computational model, the initial conditions include the gravitational constant, the masses of the planet, moon, and spaceship, and the time step delta t. The moon has a preset trajectory orbiting the planet, while the initial velocity of the spaceship is adjusted to experiment with the different orbital outcomes. All of the contributing forces of gravity between the objects are calculated in the while loop beginning at line 76. Here's the Part 2 model running. We use an initial velocity of 1 times 10 to the third x hat, 4 times 10 to the fourth y hat meters per second for the spaceship. While it did not result in a stable figure 8 orbit, the spaceship was influenced into multiple unique orbits around the planet and the moon. In Part 1, possible errors include rounding error between each location and time step, in which a smaller time step for delta t would increase the accuracy. In Part 2, the same rounding error is present from Part 1, as well as the planet is set at a fixed location, as well as the moon to a fixed orbit, leaving out forces that would greatly affect the orbits over a long period of time. Net force is the overall force acting on an object, while the rate of change momentum specifically indicates how the momentum changes over time. They are directly related through Newton's second law. The net force is the cause, and the rate of change momentum is the effect. Forces cause changes in momentum. In the same manner, the parallel and perpendicular components of net force cause a rate of change in momentum in said components. The parallel component causes a change in speed, while the perpendicular component affects its direction. To predict the motion of the entire system, you calculate the force of gravity of each object on each other. However, an estimated prediction can be made using only the dominant forces by using this tree: black hole on star, black hole plus star on planet, black hole plus star plus planet on moon.